You've probably wondered, like many of us, about our origins, right? Maybe you've even picked up Yuval Noah Harari's Sapiens. It throws some really fascinating, sometimes, well, unsettling ideas our way about our ancient relatives, those skeletons in our closet, as he puts it.
Exactly. And today we're sort of diving deeper into some of those key claims Harari makes.
Okay.
We want to put them side by side with, the latest scientific thinking. Archaeology, genetics, recent critiques.
To get a clearer picture.
Yeah, a more, let's say, nuanced picture. Updating our understanding of that world of many humans that existed before it was, well, just us, Homo sapiens.
Okay, so this idea that for a really long time we weren't alone. Who else was actually around back then?
Well, quite a few, actually. Let's start with someone like Homo erectus soloensis over in Java.
Okay, erectus.
Yeah, they were around surprisingly late. Maybe until about 100,000 years ago, give or take.
Wow, that is late.
It is. And what's interesting now is that their extinction, it seems more tied to environmental changes, like a shift in habitat to rainforest. So maybe not us directly pushing them out.
It looks like they might have disappeared before Homo sapiens really arrived in large numbers in that specific spot. It shows how even long-lasting species can be vulnerable, to ecological shifts.
Right. Okay, so what about the Neanderthals? We definitely hear a lot about them. We know we overlapped.
Oh, absolutely. Neanderthals were our contemporaries in Europe and the Near East for a very long time. And we definitely interacted. We interbred.
That's where the Neanderthal DNA comes from in many modern humans.
Precisely. That 1-2% you hear about in people with non-African ancestry, their disappearance around maybe 40,000 years ago, it wasn't just us showing up and boom, they're gone.
More complicated.
Much more complicated. Probably a mix of things. Competition, definitely. But also climate shifts, maybe diseases we brought, and even kind of assimilation through that interbreeding. It's not a simple replacement story.
Okay. And then there are the Denisovans. They seem more mysterious. We don't even really know what they look like. That's right. Most of what we know about Denisovans comes purely from DNA found in places like Siberia and Tibet. But that DNA tells us they were widespread across Asia.
And they also interbred.
They did. With Neanderthals and with us, Homo sapiens, some populations today, especially in Melanesia, carry a pretty significant chunk of Denisovan DNA, like 4-6%.
Wow.
And some of those genes are actually useful. Think about the EPAS1 gene found in Tibetans. It helps with high-altitude living, and it seems to have come from Denisovans.
So interbreeding wasn't just incidental. It actually helped us adapt.
Exactly. It contributed to our own biological toolkit, you could say.
Okay, so our genes carry these echoes. What about the famous hobbit, Homo floresiensis?
Ah, yes, the hobbit of Flores Island. Fascinating case. Very small, likely due to island dwarfism. They survived until about 50,000 years ago.
And that's close to when modern humans arrived there.
It is quite close, yes. It suggests there might have been some interaction, or at least our arrival might have indirectly impacted them, perhaps changing the ecosystem. Still debated, though.
It just paints a much, much busier picture of our ancestry than I think many people realize.
Definitely.
Now, Harari in Sapiens puts a lot of emphasis on this sudden cognitive revolution, like a switch flipped around 70,000 years ago that gave us language, fictions, large-scale cooperation.
Right. That's a central idea in the book, the supposedly abrupt leap that made us uniquely capable.
But what does the broader science say now?
Well, the scientific consensus is leaning much more towards a gradual development, not quite a sudden revolution. We have evidence, from Africa, things like engraved ochre, shell beads used as ornaments that date back much earlier.
How much earlier?
We're talking 75,000, even 100,000 years ago or more. This suggests that symbolic thinking, the basis for fictions, was emerging over a much longer period. It wasn't a sudden event, more like a slow burn.
So the ability to think abstractly, cooperate in huge groups, it didn't just appear overnight.
It seems unlikely based on the current archaeological and genetic evidence. Many scholars critique that revolution idea as maybe a bit too simple, lacking really strong evidence for one single abrupt event that changed everything.
Okay, and this ties back to the interbreeding, right?
Yeah.
It shows we weren't completely separate biologically or maybe even cognitively.
Exactly. The fact that we carry Neanderthal and Denisovan DNA isn't just a cool fact. These genes, as we mentioned, have functions. They've contributed to our immune systems, our adaptation to environments. Our origins are really a story of mixing, of interconnectedness. We're a genetic mosaic.
So the big takeaway here seems to be that human evolution is far more complex, maybe messier, than just a straightforward story of Homo sapiens being destined to win out.
Precisely. Coexistence was the norm for a long time. Interbreeding happened.
Right.
And the disappearance of other hominins, likely down to multiple factors: climate, competition, maybe disease, absorption into our gene pool. It wasn't a simple conquest.
So perhaps those skeletons in our closet aren't just about the fact that other humans existed and went extinct. Maybe it's also about the overly simple stories we sometimes tell ourselves about why they disappeared and how we came to be alone.
I think that's a great way to put it. The story keeps getting richer, more intricate as we find more evidence. Ongoing discoveries are constantly reshaping how we see ourselves and our place in the very diverse human family tree.
Makes you wonder what else we'll uncover, doesn't it? What other complexities are waiting in our deep past?
Absolutely. It suggests our history is even more interwoven and fascinating than we might currently grasp.